ProVision ISR has developed its own proprietary analytics engine called DDA, which stands for Detect, Distinguish, and Alert. At its core, DDA analytics are based on object recognition, focusing on three primary object types: people, two-wheel vehicles, and four-wheel vehicles. Using these objects, the system allows users to define intelligent rules, such as line crossing and sterile area monitoring. For example, alerts can be triggered when an object crosses a line in a specific direction or enters a predefined area. These rules also enable object counting, threshold-based alerts when limits are exceeded, and automated reporting that delivers valuable operational insights. More advanced time-based analytics combine object recognition with duration rules, enabling features such as loitering detection for people and illegal parking detection for vehicles. Users can define how long an object is permitted to remain within a specific area before an event is triggered. Building on this foundation, ProVision ISR introduced its second-generation analytics, which extend beyond object identification to include attribute recognition. For people, attributes such as gender, approximate age, clothing color, and the presence of glasses can be identified. For vehicles, the system can determine color, vehicle types such as bus, SUV, or pickup, and manufacturer. These attributes are stored in the MVR and can be searched post-event, significantly accelerating incident investigation. Additional analytics include face detection and recognition, license plate detection and recognition using dedicated LPR cameras, and thermal analytics, such as fire detection and temperature monitoring. The solution is further enhanced with built-in parking lot management applications within the NVR and VMS software, as well as automatic PTZ tracking, allowing the system to intelligently track people and vehicles in real time. Line crossing analytics detects when a person or vehicle crosses a defined virtual line, triggering alerts or automated actions. It's perfect for perimeter security, detecting vehicles traveling the wrong way on a one-way street, or even identifying exiting vehicles to automatically open gates. Let's see line crossing analytics in action. We've drawn a virtual line, configured to detect only two-wheel vehicles and ignore all other objects. As soon as a two-wheel vehicle is identified crossing the line, the system triggers a full-screen video pop-up, providing immediate visual confirmation in real time. On the top right camera, we're using line crossing analytics with a PTZ camera to detect vehicles moving from right to left. When a vehicle is detected, the system automatically triggers PTZ tracking, following the vehicle in real time for enhanced monitoring and situational awareness. Moving on to sterile area. Sterile area analytics monitors a defined zone and triggers alerts whenever unauthorized objects enter it. You can set it to detect specific types, like vehicles or people, and ignore others, making it ideal for restricted areas, no parking zones, or sensitive public spaces. Let's see sterile area analytics in action. In this example, we've configured two areas to detect humans while ignoring vehicles. The moment someone enters either area, a full-screen video pop-up immediately alerts the operator in real time. Even if the person moves into the second area, the system generates a new event, ensuring nothing goes unnoticed. Next, let's talk about metadata analytics. Our AI can identify key attributes of people, vehicles, and two-wheel vehicles. After an event, you can search using these attributes, making it faster and easier to locate specific incidents and fine-tune your investigations. Let me show you two real-life examples. In the first scenario, an incident occurred in a parking lot where an eyewitness reported a white Citroen driving into another vehicle and leaving. Using the analytics search engine in our NVR, we can input the vehicle's color and manufacturer to quickly locate potential matches. From the search results, we can deep dive into each incident and, if needed, review the footage in full screen for complete verification. With just a few clicks, you can quickly and accurately pinpoint the events you need. No more scrolling through hours of irrelevant footage. In the second scenario, a person took a roll of cable from a store without permission. The store manager described the individual as a male wearing a black golf shirt. By entering these attributes into the search engine, we quickly narrowed down the results. Notice how many attributes are available for humans. Whenever you can search for an attribute, it means our AI can accurately detect and identify it. On the second result, we identified the person holding the cable. Clicking the snapshot gives an instant 7-second preview, and we can explore further using the snapshot details to view additional attributes. Notice how the search results include additional attributes that you didn't specifically select. Our AI automatically identifies and highlights these, giving you even more insight from each event. From there, we can play back the full incident and even export the footage as evidence. These examples highlight how metadata analytics allows operators to rapidly locate and investigate incidents using attributes, saving time and improving operational efficiency. Next, let's look at loitering and illegal parking analytics. The principles behind both are similar. They rely on object recognition within a defined area, and an event is triggered only if the object remains beyond a predefined time threshold. Loitering analytics focuses on humans. Illegal parking analytics focuses on vehicles. For example, you could monitor someone loitering near an ATM or track how long a person stays in a hospital waiting area. If the time exceeds the defined threshold, the system can notify the shift manager and record the incident for operational insights. Illegal parking can be used to alert if a driveway is blocked too long, or to improve operational efficiency by notifying managers if loading zones are occupied beyond the allowed time, or if vehicles and car washes are taking longer than expected. Both analytics help organizations enhance security and improve operational efficiency by combining object detection with time-based rules. In this case study, employees were taking smoke breaks in the parking area, which was against company policy. The solution was to create a loitering area with a 15-second time threshold and trigger an audible siren if a loitering event occurred. The loitering area is defined in blue. As soon as a person enters the area, a countdown begins. The countdown you see here is for graphical representation. In this example, the first person did not exceed the 15-second limit, so no alarm was triggered. When the same person re-enters the area, a new timer starts, and if additional people enter, each person gets their own countdown. The event is triggered as soon as any individual exceeds the time threshold, ensuring precise monitoring of all activity in the defined area. Let's move on to object counting. Our AI can count humans, two-wheeled vehicles, and four-wheeled vehicles, either by line crossing or within a defined area. Counting is just the start. You can also set thresholds for object counts, trigger alerts when thresholds are exceeded, and reduce false alarms by specifying how long a threshold must be exceeded before an event triggers. The system can generate automated reports daily, weekly, or monthly, helping you identify trends, like the busiest day in a store. This insight supports smarter decisions, such as deploying extra cashiers or security staff during peak times. Now, let's see how it works in action. For this area counting example, we've set a threshold of 3 people. If the threshold is exceeded, the on-screen display changes to "Please wait," and a video pop-up is triggered. As people enter the defined area, the entry count increases, and the stay count reflects how many are currently inside. When another person enters and the threshold is exceeded, the OSD updates and the pop-up occurs. As people exit, the exit count increases and the stay count decreases accordingly, giving operators a real-time view of occupancy and helping manage space efficiently. Face detection analytics is a video analytics feature that automatically identifies human faces within a camera's field of view. Once a face is detected, the system captures a snapshot and sends it to the NVR for storage. Face recognition takes analytics further by introducing databases where snapshots can be assigned names. When a face is detected, the system sends the snapshot to the NVR for real-time comparison against these databases. Each database can have its own schedule and rules. For example, a block list can trigger a siren.
A VIP list can notify staff when a key client arrives, and databases can also support whitelist or access control. Managing databases is simple. Our Cam2 mobile app doubles as an enrollment reader, making it easy to add new faces on the go. Beyond real-time alerts, face recognition is a powerful tool for post-event investigations. You can search events based on recognition matches, and by using an EMAP, upload a floor plan with cameras mapped to their real locations, you gain a visual and geographic view of where each individual was detected, making it much easier to analyze incidents and track movement patterns. Let's see how we can use face detection, face recognition, and EMAP tracking to identify an employee's behavior. Start with the analytics face search by defining a date range and uploading a target picture. This picture can come from a face database, a snapshot gallery from previous face detection events, or an external source, meaning you can search for individuals even if they're not in a database. Once loaded, the system searches for matching results within that date range. Each result shows the time of the event, the camera it occurred on, and a confidence percentage indicating how closely the snapshot matches the target. You can scroll through results and play back footage as needed. Using a preloaded EMAP, you gain a visual and geographic view of the incident. The EMAP highlights which camera detected each event, provides a 7-second preview, and lets you move through events in chronological order. You can also trace the individual's movements along defined paths. With all this information, you can identify patterns and address any unwanted behavior efficiently.
A key topic is how to react to any analytic event. With Provision ISR, every event can trigger automated actions that help operators respond faster and more effectively. You can send push notifications to the mobile app or automatic emails to multiple recipients. Snapshots and video can be captured not only from the camera that detected the event, but from any combination of channels, providing full context around an incident. Events can trigger video pop-ups and audible alerts on the NVR, ensuring that nothing is missed. You can also trigger alarm outputs, not only from the NVR, but also from connected cameras and I/O extension boxes, to activate third-party devices, such as sirens and strobes for instant physical response. In addition, you can control PTZ cameras to move to predefined presets, activate active deterrence cameras with lights or sound, and play automated audio messages through IP speakers. This may seem complicated, but when you look at the NVR user interface, it's actually very straightforward. Any analytic configuration provides the same trigger options, so once you learn it, you can apply it everywhere. You simply enable the required triggers by clicking the relevant checkboxes. You select which cameras will record based on the event, configure up to 16 alarm outputs to activate simultaneously, and custom name each output so you know exactly what is being triggered. You can also set PTZ cameras to move to pre-configured presets, and select from a drop-down list which audio files should play automatically when the event occurs. For this single event, all actions are automatically coordinated, making response seamless and effortless. Let me introduce a powerful feature in Provision ISR's analytics toolbox, Combined Alert. Think of it like a logical if statement. If event A and event B happen at the same time, only then does the system trigger an action. In Provision ISR, this means 2 or more conditions must occur simultaneously for an alarm or trigger. That's a combined alert. So what can you combine? Many things. Sensor inputs, like a door contact and PIR sensor triggering together. DDA analytics, such as line crossing from 2 cameras. Mixed analytics, like line crossing on one camera and sterile area detection on another. Even face recognition results combined with a sensor input. The key point, all conditions must occur simultaneously for a reaction. This gives greater control over alerts, reduces false alarms, and boosts system intelligence, a capability unique to Provision ISR. Here's a real-world example. At an intersection, we wanted to capture license plate snapshots, but only when a vehicle runs a red light or stops over the white line while the light is red. No green light triggers. The solution? Combined alerts. Condition 1. AI line crossing detects a vehicle crossing the stop line.
Condition 2, a traffic light sensor closes a relay when the light turns red. Only when both conditions are met does the system register an event. If the light is green, even if a car crosses the line, no event is triggered. When the light turns red and a vehicle stops over the line, both conditions are satisfied. The system captures a license plate snapshot using an LPR camera. This ensures snapshots are taken only at the right moment, avoids false triggers, and delivers precise, actionable evidence.